Interpreting a stem and leaf plot using mean, median, mode, and range. So this particular stem and leaf plot has to do with math test scores. If you look at the key, it is 8 with the line and 3, which means 83. So this separation between the stem and the leaf means that we are separating the tens over here from the ones places over there. So this number here means 65. This is 68, 70, 71, 77, 78, 83, 84, 84, 85, 85, 86, 87, 89, 90, 90, 90, 92, 92, and 96. So the largest value in this particular stem and leaf plot is 96. And the smallest number is 65. There are exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pieces of data in this data set. So 20 pieces of data. So this is going to come in handy whenever we find the mean, because we're going to have to add all of those numbers together and divide by 20. Knowing how to find the largest and smallest number is going to be helpful for range. So your largest number is always the very last stem and the very last leaf. Your smallest number is always the very first stem and the very first leaf. So that's an easy way to remember that. It's last and first. Just like if you were to put it in order from least to greatest, 65 would be first and 96 would be last. Okay, so we're going to do mean, which is the average of all of the data in the data set. The median is the number in the middle of the data set. The mode is the number that you see the most in the data set. And your range is the difference between the largest number and the smallest number. So because I already know the largest and smallest number, I'm going to go ahead and do my range first. So we're going to do 96 minus 65. 6 minus 5 is 1. 9 minus 6 is 3. This 31 means that there are 31 pieces of data or numbers in between 65 and 96 on a number line. So now the mode is the number that you see the most. So we're going to visit each stem, and then we're going to look at the leaves and see if there are any leaves that repeat themselves and how many times do they repeat themselves. We're looking for the leaf and the stem that have the most repetition. So this is 65, 68. There is no repetition in that set of numbers. 70, 71, 77, 78. Once again, there is no repetition. 83, 84, 84, 85, 85, 86, 87, 89. So you notice that I said 84 2 times and I said 85 2 times. Then I look at 90. I have 90, 90, 90, 92, 92, 96. So there's repetition here 3 times, and there's repetition here 2 times. So the leaf and the stem that are represented the most amount of times is 90, because there are 3 90s in this data set. There's only 2 84s, 2 85s, and 2 92s. So the mode is 90. That is the number that appears the most. And the median is the number in the middle. So for this particular situation, I'm going to go ahead and list all the numbers from least to greatest so that we can find the number that is in the middle. So we have 65, 68, 70, 71, 77, 78, 83, 84, 84, 85, 85, 86, 87, 89, 90, 90, 90, 92, 92, and 96. So remember, in order to find the number that's in the middle, all I need to do is mark out a low number and a high number, low number, high number, low number, high number, until I end up with the number in the middle. If I have 2 numbers in the middle, I'm going to add those 2 numbers together, and I'm going to divide by 2, and I'm going to get an average median. So I'm going to mark out 65 and 96, 92, 68, 70, 92, 90, 71, 77, 90, 90, 78, 83, 89, 84, 87, 84, 86. So I actually have two numbers in the middle, and they're both actually 85. So both of these numbers are 85, which means if I add them together and I divide by 2, I'm just going to get 85 again. So the median of my set of data is 85. And now I'm going to do the mean. The mean is the one that's probably going to take the most of your time because you're going to have to add together all of these numbers and then divide by 20, because remember there are 20 pieces of data, and we know that because there are 20 leaves and each leaf represents a different number. So I'm going to add together all of my 60s, all of my 70s, all of my 80s, and all of my 90s, and I'm going to take those four numbers and add them together. I'm just going to do smaller chunks, that way it makes my life just a little bit easier. So I have 65 plus 68. So 8 plus 5 is 13, so I'm going to put a 3, carry a 1, and then we know that it's 2 6s because 65 and 68, so that's 12 plus 1 more is 13. 7 plus 1 is 8, plus 8 is 16, so I'm going to put a 6, and I'm going to carry a 1. Now, there are 4 7s because this is 70, 71, 77, and 78. So 70 times 4 is 280, plus 1 more. So 7 times 4 is 28, plus 1 more is 29. So I have 296. Then I'm going to do the same thing here. So I have 9, 16, 22, 27, 32, 36, 40, 43. So I'm going to put a 3 and I'm going to carry a 4. So there are 1, 2, 3, 4, 5, 6, 7, 8 8s. So 8 times 8 is 64, plus 4 more is 68. 2 plus 6 is 8, plus 2 more is 10, so I'm going to put a 0, carry a 1. And this is 90, 90, 90, 92, 92, 96. So I'm going to take all of those 9s that belong in front and add them together, or just multiply by 6. So 9 times 6 is 54, plus 1 more is 55. So now I'm going to take those four numbers and I'm going to add them together. 683, 550, 296, and 133. So that is 6 plus 6 is 12, carry a 1. That is 9 plus 9 is 18, plus 5 is 23, plus 3 more is 26. Then I have 6, 7, 8, 13, 14, 15, 16. So 1,662 divided by 20. So just a rule of thumb, my answer should be relatively close to 85 because these numbers are all kind of clustered together. There's no extreme outliers. So there's not a number that's extremely lower than the rest, and there's not a number that's extremely higher than the rest. Therefore, it's not going to skew my mean. So if I have 1, I cannot make a group of 20. If I have 16, I cannot make a group of 20. If I have 166, I can make 8 groups of 20, which is 160. Leaves me with 6, bring down a 2. So if I have 62 and I want to put them into groups of 20, I can put them into 3 groups of 20. That leaves me with 2, add a decimal, and bring down a 0. If I have 20 and I want to put it into groups of 20, that means I can make 1 group. So my answer is 83.1. So 83.1 is relatively close to 85. So I know that my group of data is accurate and matches, and I didn't mess anything up. If you want, you can go back, you can use a calculator and add all of those together, divide it by 20, and then see if you get the same answer, which you will. I just kind of did it a faster way.